Hello, everyone, and we're back. This is your live coverage of the landing of Mars Insight probe. I am going to pull up the coverage that is coming to us from the NASA TV and begin co-streaming it in just a moment. So here we go.
After traveling through space for more than 6 months and crossing 300 million miles, InSight has reached its destination, the red planet Mars. Welcome to Mission Control at NASA's Jet Propulsion Laboratory. I'm Ye Hill. Less than an hour from now, InSight will begin the most harrowing 6.5 minutes of the entire mission, EDL, Entry, Descent, and Landing. The team is as prepared as it can be, but who knows what Mars has in store today. The crew's mission support area is filled with engineers monitoring the situation, and for the first time during a Mars landing, you can be in the room too. We have a 360-degree camera in this control room, allowing you to experience the landing right along with the team. There you see it. And to look up the link, just go to the InSight watch page you see there on the screen. And this mission has actually 2 control rooms. The second is at Lockheed Martin Space outside of Denver, Colorado. Engineers there are on Console 2. Plus, people all over the world are tuning in at museums and libraries and other locations, including this one at the Pasadena Convention Center, and that is where friends and family are watching right now. There will also be an opportunity to watch in New York City. There they are cheering. There will be also an opportunity to watch in New York City when landing coverage gets displayed on the NASDAQ tower you see there in Times Square. And of course, if you are watching, please snap a picture and share it with us using the hashtag #MarsLanding. We'd love to see it. Now I'd like to introduce you to NASA Administrator Jim Bridenstine. Thank you for coming.
Oh, it's my honor. Thank you for having me.
We're so excited to have you here.
Great to be here.
So this is your first Mars landing.
It is. In this job. Now, I have witnessed these as, I should say, from the sidelines for many years. This is going to be the 8th time that we have a successful landing on Mars. Everybody knock on wood.
That's right.
But this is the first time for me to participate as the administrator. So.
You don't say that. That's like wishing an actor good luck. That's how you crash a spacecraft.
Nervous.
All right. So we hope to have you back on set after landing and maybe take a couple of social media questions.
Absolutely.
All right. If you would like to ask the administrator a question, use the hashtag #AskNASA. And before you go, you did ask about the Lucky Peanuts.
Yes.
So this is your bottle to take in there.
Happily munching on these.
All right. Thanks for joining us.
You.
Now let's give you some background. InSight, in short, is short for Interior Exploration using Seismic Investigations, Geodesy, and Heat Transport. It's different from other Mars missions, which all studied the surface. InSight is the first mission to study the interior of the red planet.
The basic idea of InSight is to map out the deep structure of Mars. We know a lot about the surface of Mars, we know a lot about its atmosphere, and even about its ionosphere, but we don't know very much about what goes on a mile below the surface, much less 2,000 miles below the surface down to the center. And this will be the first mission that's going to Mars specifically to investigate the deep inside of Mars.
We know that the Earth is habitable, we know that Mars is not. There might be something that we find out in terms of the structure of Mars versus the structure of Earth that maybe can help us understand why that is.
InSight carries a seismometer which measures the seismic waves that have traveled through Mars from Mars quakes and maps out the deep interior structure of Mars.
We're going to also have a heat flow and physical properties probe which will penetrate into the Mars surface about 5 meters or 16 feet to take the temperature of Mars.
And it has a radio science experiment which uses the radio on the spacecraft to measure small variations in the wobble of Mars's pole to understand more about the structure and composition of the core.
InSight will be the first mission to pick instruments up off the deck of the lander and place them on the surface of Mars. I like to say that we're playing the claw game on Mars with no joystick. The seismometer needs to be installed in one place and basically not move in order to get the best seismic data.
We also have a wind and thermal shield that will then be placed on top of that seismometer to protect it further from the environment.
For the heat flow probe, HP cubed, it also needs to sit in one place, take a while to hammer itself down into the ground and acquire the thermal measurements over a long period of time.
InSight is a mission to Mars, but it's much, much more than a Mars mission. In some sense, it's like a time machine. It's measuring the structure of Mars that was put in place 4.5 billion years ago, so we can go back and understand the processes that formed Mars just shortly after it was accreted from the solar nebula. By studying Mars, we'll be able to learn more about Earth, Venus, Mercury, even the Moon, even exoplanets around other stars.
Landing on Mars is always difficult. More than half the missions have failed. Our experts in this field are systems engineers for entry, descent, and landing. They speak EDL. Let me introduce you to two in our control room, Christine Soleil, who will be making the mission callouts during landing, and Julie Wirtz-Chen. She is our color commentator who will help explain mission operations. Christine, let's start with you. I understand that there was a final software update and adjustment. What does that mean?
That's right. Yesterday we sent the last EDL software parameter update to the spacecraft's computer. This update told the spacecraft exactly when it will hit the top of the atmosphere and also fine-tuned things like when to deploy the parachute. This EDL software is very important because InSight uses this software to perform entry, descent, and landing completely on its own. Mars is so far away from Earth that when a command is sent from Earth, it takes about 8 minutes for it to reach the spacecraft. Entry, descent, and landing from start to finish is less than 8 minutes long, so InSight has to do this all by itself.
All right, its fate is sealed. Now I understand that the team is about to do a readiness poll. Julie, can you fill us in on that?
Sure, so that's going to be a poll between our EDL communications engineer and several of the different orbiters and antennas that we have here on Earth. So we have Marco listening in on us, and MRO, which is Mars Reconnaissance Orbiter, will be listening to our data and recording it for us. And then the radio science engineers will be eavesdropping in on our signal from all the way back here on Earth. And Sandy, our EDL communications engineer, will be checking in with them, making sure that they're all ready to go, ready to support us in just a little, under an hour to land on Mars.
All right, so we're standing by for that
Yep.
readiness poll. And I understand that the peanuts are going to be passed in there pretty soon?
I believe that's the idea. Yeah, we'll be passing around the peanuts very soon after that. For those of you who don't know, the JPL peanuts are a tradition that gives us a little bit of extra luck on our critical events. So if anybody out there wants to join in on peanuts and give us some extra good luck peanut vibe, we'd love to have it.
Well, there's a story behind that way back when in the early days of JPL, there were several missions, and there were 6 Ranger missions to the moon that failed.
Yep.
But then with Ranger 7, somebody passed around peanuts.
Yeah, and it worked, and you don't mess with what works. So
Absolutely.
It's not a superstition, it's a tradition. And we just give ourselves that little bit of extra luck.
All right. So if you have peanuts at home, please have some.
That's right.
All right.
That's right.
Thanks, Julie.
Thanks.
NASA has had 7 successful Mars landings, but the EDL team never, ever becomes overconfident. JPL Chief Engineer Rob Manning says things have to work just right during 6.5 critical minutes.
Although we've done it before, landing on Mars is hard, and this mission is no different. The process to get from the top of the atmosphere of Mars to the surface, we call entry, descent, and landing, or EDL. It takes thousands of steps, to go from the top of the atmosphere to the surface, and each one of them has to work perfectly to be a successful mission. The process starts well above the top of the atmosphere of Mars. The cruise stage faces the sun. It also has its radio antenna, which faces Earth. But now we don't need the cruise stage. Its job is done. The next step, just 7 minutes before arriving to the top of the Mars atmosphere, is to separate the cruise stage. Before you hit the top of the atmosphere, though, the space capsule has to orient itself so that the heat shield is precisely facing the atmosphere. Now the fun begins. The vehicle is moving at nearly 13,000 miles an hour, but it's hitting the top of the atmosphere at a very shallow angle, 12 degrees. Any steeper, the vehicle will hit the thicker part of the atmosphere and it will melt and burn up. Any shallower, the vehicle will bounce off the atmosphere of Mars. At the very top of the atmosphere, it's about 70 miles above the surface of Mars, and the air is starting to get thicker and thicker and thicker. As it does that, the temperature on the heat shield gets well over 1,000 degrees centigrade, enough to melt steel. Over the next 2 minutes, the vehicle decelerates at a backbreaking 12 Earth Gs, from 13,000 miles an hour to about 1,000 miles an hour. At about 10 miles above the surface of Mars, a supersonic parachute is launched out of the back of the vehicle. 15 seconds after the parachute inflates, it's time to get rid of the heat shield. 6 pyrotechnic devices fire simultaneously, allowing the heat shield to fall and tumble away from the vehicle, exposing the lander to the surface of Mars. 10 seconds after the heat shield is dropped, 3 pyrotechnically deployed legs are released and locked for landing. About a minute later, the landing radar is turned on, sending pulses toward the surface of Mars as the vehicle starts to try to measure how high it is above the surface and how fast it's going. At about a mile above the surface of Mars, the lander falls away from the back shell and lights its engines. And very quickly, the vehicle must rotate out of the way so that the parachute and the back shell doesn't come down to hit it. The last thing that has to happen is that on the moment of attack, the engines have to shut down immediately. If they don't, the vehicle will tip over. So if all the steps of entry, descent, and landing happen perfectly and we are safely on the surface of Mars, we'll be ready to do some exciting new science.
Later on in the program. Meantime, let me introduce you to someone who has been working on InSight for 7 years. He's the project manager, Tom Hoffman. 7 years, and today's the day.
That's right, 7 years, but we're just a little over 40 minutes now, and we're going to be on the surface. It's going to be awesome.
Really exciting
All
stuff.
worth it.
All right, so let's talk about InSight. It's using tried and true technology. It's based on Phoenix. This time, there's a bigger challenge with communication, correct? Normally, we have an orbiter that can give us bent pipe communications, but it's different this time.
That's right. And most of the time when we've landed recently, we've had Mars Odyssey, which can do bent pipe communications, and so we get real-time data as we go through EDL, and we've come to expect that, and actually we really, really want that. In this case, our primary technology, primary orbiter is Mars Reconnaissance Orbiter. And so what that's going to be doing is actually, will be listening to us on the UHF. If you go to the video, you can see this. MRO will be listening to us and be getting all the primary data, and it will send it back to us, unfortunately, only at 3 hours after we land.
So it doesn't give us the bent pipe live information.
It doesn't. And we have a couple of other sources that we're looking at. We have a Green Bank Observatory in West Virginia, Max Planck Observatory in Effelsberg, Germany, which will be giving us UHF, but those only give us a couple of different points in time. And so we did something kind of cool this time. We brought along a couple of CubeSats called Marco. And so hopefully they're both working great today.
Oh, fantastic.
So we're hoping that they're going to continue to work all the way through EDL, and they will be giving us real-time feed. So we can show how that works on the next video here.
There they are.
So you can see here's InSight with its cruise stage, getting close to Mars. But we have 2 stalkers following us. They've been following us since we launched. They launched on the same launch vehicle as us. And so you can see the green there is we're sending UHF signals to them. And then they turn that around and send a much stronger signal back to Earth. We can't communicate on UHF direct to Earth with a signal that tells what's going on in the spacecraft, but Marco can. If it works for us all the way down to the surface, we're going to have some great information coming from Marcos.
So Marco is basically trying to fill that gap that we would have had if we had live communication coming down to us.
Absolutely.
So if it does not work, does it affect InSight's mission at all?
No, not at all. We'll just be doing a little more nail biting, but right now it looks like it's gonna be working, but it doesn't impact InSight at all. And we have one final way that we're going to know that we've got successfully to the ground, which is the spacecraft will phone home.
Okay.
Once it gets down to the ground, it'll have gone 7 months through cruise, 7.5 minutes of tear, and it's going to call back and say, hey, I'm on the surface, I'm feeling pretty good, everything looks good so far.
And also to prep the audience, they're not, even after landing, we're not out of the woods just yet, correct?
Not just yet. We have one more step that we have to do. We have to let the dust settle, quite literally. We're going to kick up a lot of dust when we land. We need to let that dust settle before we want to unfurl our solar rays. We're 100% solar powered, so it's very important that we get those out. Unfortunately, both MRO and Marco will be out of view by the time that we have those completely unfurled. And so we're going to have to wait 5.5 hours until Odyssey comes by and tells us that, yes, indeed, our solar arrays are out. So we'll definitely have a celebration when we get successful landing, but we're going to have to temper that just a little bit and wait about 5.5 hours to know absolutely for sure we're in good shape.
So we have immediate knowledge if we have the Marcos. So just to run it through it once again, what's going to happen with EDL? We have the video, the show. How exactly is this all going to play out in 6.5 minutes? And we can roll the video.
Okay. Yeah, so you can see here we're attached to the cruise stage. We drop that off, say thank you for the ride to Mars. It burns up in the atmosphere. You can see it gets very hot on our heat shield. We're getting up in some places maybe 3,000 degrees Fahrenheit as we go through this. We're on the heat shield for about 4 minutes. That dissipates about 90% of the energy that we need to dissipate before we get to the surface. Then we pop our parachute. We're going about 850 miles an hour when we pop the parachute. We're on that for about 2 minutes. Then we'll drop off the heat shield. We'll start acquiring the ground with our radar, very much like an F-16 fighter jet radar. The legs will pop out. We'll start descending. We drop for just a second, which is very terrifying for me. Our descent thrusters, we have 12 of them. They're 68-pound thrusters. Start thrusting and dropping us to the ground. And slowly, slowly, we drop down, going only 5 miles an hour. So in that 6.5 minutes of tear, which is a little less than the 7 minutes, so that's great for me, we go from 12,300 miles an hour at 75 miles above the surface of Mars. We get to the surface, we're at 5.5 miles an hour.
That's amazing. That is absolutely amazing. Well, before you go, Tom, there was a couple of pictures we wanted to show you. We have watch parties taking place all over the country, and let's see if we can put one of these watch parties up for you to see. This is from Ohio. This is a person who has a watch party. It looks like in a classroom.
That is so awesome.
Isn't that great that folks are watching with us?
Yeah, I know people all across the globe are watching this, and we really want to put on a good show for them today.
All right. Well, I'll let you back in the room.
All right, I got to get back in there.
I know you're excited. All right, take care. Thanks for joining us.
Thank you.
Question about what would Mars smell like. Let me lower the volume on that. So to answer the question about what would Mars smell like, our ability to smell is a feature of 3 different things, and I'll go back to her if it's particularly interesting. So they're introducing more humans, so I'm going to take a moment to answer this question. So our ability to smell is based on there being stuff to smell, that stuff being conducted by atmosphere to our sinuses where our smell sensors are located, and the ability of that stuff to be smelled is often compounded or taken back by the dryness of the air. So with Mars, you don't have a lot of air to carry the smells. The air is super dry, which will dry your sinuses, limiting your ability to smell. And then you would die if you tried to smell for too long because there isn't enough oxygen or air pressure, and all of these things would cause hemorrhaging in your lungs and death. So the comment that it smells like asphyxiation is fairly adequate. I'm going to go back. So they're talking about how they're going to land. I'm going to bring back the discussion on how they're going to land.
In addition, we're a little bit heavier than Phoenix was, so we've had to increase some of the strength of some of the lander itself. So the parachute, we have had to increase the strength. We actually deploy the parachute a little bit higher because of some of the differences in our entry timeline. And because of when we're landing towards the end of dust season, so we also have actually increased the thickness of the heat shield. So we're about a 1/4 inch thicker on our heat shield to accommodate that potential sandblasting that we could see when we actually do our entry, descent, landing. So a number of things we've changed, but we've obviously leveraged a lot from the very successful Phoenix mission as well.
That's fantastic. So you were able to kind of customize it, because there were some concerns earlier on that there was a dust storm taking place. It was dust storm season.
That's right. In fact, we've had a lot of great support from our orbiting assets, MRO and Odyssey, a couple of spacecraft that we've partnered with JPL and that were built here at Lockheed Martin. They've actually provided a lot of great...
So I'm going to mute him out and answer some of your questions. So related to your question about what is the plan for dust storms, they actually have radar on board, so they can land without being able to see anything in visible light. Instead, they're reflecting radio waves off of the surface using that radar and landing safely without needing functional eyeballs. So that's the current plan. So this mission is several years. I will find the exact length and bring it to you in chat. So she's saying that we're 20 minutes away. I'm going to go back to their coverage.
Stage separation, it's not too far off. Cruise stage separation is expected at about 40 minutes past the hour, so we are indeed getting close. So where is InSight going to Mars? It's a place called Elysium Planitia. Planitia is Latin for flat. Elysium is ancient Greek for afterlife paradise. It's located near the equator, north of Gale Crater, not too far from Curiosity rover. The team calls it the biggest parking lot on Mars. It's a place that's safe, got plenty of sunshine, that will power solar instruments to study the interior of Mars.
What's inside Mars? We know a lot about what's inside Earth. But at Mars, we've only just scratched the surface. To learn how Mars formed, we have to study its deep interior. NASA's InSight lander was designed to do just that, by taking the planet's vital signs. Listening for its pulse or seismic activity, including any Marsquakes. Taking its temperature to see how much heat is flowing out from deep inside. And checking its reflexes to see how much the planet wobbles as it whips around the sun. These all provide clues to what the planet is really like inside. So what's inside Mars? InSight can help us find out by giving Mars its first thorough checkup since it formed 4.5 billion years ago. The more we learn, the better we'll understand all the rocky planets and the history of our solar system.
Joining us now is Bruce Bannard, the principal investigator of Mars Insight. InSight is a mission to Mars, but we keep hearing again and again it's more than a mission to Mars.
That's right, Gay. I mean, we're going to Mars, obviously, to study the Martian interior and to map out the divisions inside Mars, but we want to use that information to understand more about the solar system as a whole and how rocky planets form.
And rocky planets, we have an image to show folks. So we're talking about Earth, the Moon, Mars.
Mercury, Venus, yes, the planets of the inner solar system that are made mostly of rocks. And they all share the same basic structure with a dense iron core, a rocky mantle, and then a crust of lighter silicate rocks. But the very details of the thicknesses of those layers, the sizes, and the compositions give us a lot of clues as to how those planets form and why they went down very different paths into the different planets we see today.
So explain to me, we are going to have a lander, you're going to be on the surface. How will you be able to study the interior
Well, we use what are called geophysical instruments. They use the principles of physics to actually see through the rocks. I mean, we're using seismic waves. It's the same way you might use a flash bulb to take pictures of something. We're using Mars quakes, which send out vibrational waves through the planet, and as they go through the planet, they...
Okay, I'm going to give you a slightly more complicated understanding of this. So as the waves, what they're showing right now, these are the primary waves, the P waves, they're compression waves that move through, and the way the pressure waves move through, which move through both rocks and liquid, allow us to measure one way through the center. There's also S waves, secondary waves, slower waves that are oscillation waves that only move through solid rock. By combining measurements of these two different kinds of waves, we're able to figure out what the core is, because the S waves have to go around the core and the P waves go through the core. Now, what they're discussing now is here on the Earth, we use multiple seismometers to figure out where a seismic event originated. This is how we figure out something beneath the surface versus on the surface. This is how we get the depth, the three-dimensional position of something. So here we see the waves moving across Mars. Now, what they're relying on Mars, instead of multiple seismometers, what they're relying on is Mars is tiny, and these waves can go around Mars' surface or ricochet through the interior multiple times, allowing the same waves to, well, go back and forth different times, providing additional information that can be used to figure out exactly where these earthquakes originated. I don't know how newscasters never lose their earpieces. So I'm going to go back to what he's talking about.
And very quickly, there is still another instrument built by DLR that's also being carried up by InSight. Can you talk a little bit about that?
Yeah, that's our heat flow probe, and it's a pretty cool instrument that uses a mechanical mole, we call it, to burrow its way down into the surface. It has a motor with that winds up a hammer, and it knocks itself down just a few millimeters at a time. But we do that 20 or 30,000 hammer strokes, and it gets us down. We hope to get down to be about 16 feet below the surface. And once we get down there, we're actually measuring the heat coming out of the planet by measuring the temperature along the cable as it comes up to the surface, and looking at how that temperature increases as we go down, and extrapolate that deep into the planet to understand how much energy there is inside the planet to drive the geology and to drive volcanism, Mars quakes, all kinds of activity.
It's amazing how much you'll be able to learn from the surface about the interior.
That's right. I think it is amazing, and it's been something that I've been working on for my whole professional career, and it's just, I find it fascinating. But
all right, we'll talk about that. Thanks, okay. Bruce. Bruce first thought of a mission like this, as he mentions, 40 years ago when he was a graduate student. The rest of the team hasn't waited quite that long, but this is a big moment for them too. Recently, we sat down with a few of the members and asked them, what is it going to be like as we get close to landing?
It's a very difficult thing to do, and everything has to go perfectly. As humans, we've sent 17 different missions to the surface of Mars, and 10 of them have crashed. Before we can land on Mars, we have to get to Mars. How do we get to Mars?
The main responsibility of the navigation team is to ensure that the spacecraft is delivered to the right point at the top of the Martian atmosphere. The target location is about 12 kilometers in size. Our accuracy is comparable to shooting a basketball from Staples Center in downtown LA and hitting nothing but net in a basketball hoop in New York City that is moving at a speed of about 2 feet per second and is spinning about its axis.
The landing site, we have an ellipse that's pretty big. It's about 60 miles long. We could land anywhere in that ellipse. There's a chance that we could land right on a rock, and we don't really have any control over that, so that's what makes me nervous.
We've tested the radar by flying it on a helicopter. We've tested pieces of the heat shield by putting them in an arc jet facility. We've tested the parachute by testing it in a wind tunnel. And putting all that together in a very tightly controlled sequence where every single thing has to go right, we've never tested that. And the first time it's going to happen is once you deliver us to Mars.
It is about 11:29 a.m. Pacific, and you're watching live coverage of the InSight landing from NASA's Jet Propulsion Laboratory in Pasadena, California. We are about a half hour away from landing, and people all over the world are watching. Take a look at a map that we have for you. We can show you right now. This is a watch in person map where people have watch parties all over the world, all over the United States, in Paris, in Berlin, even off the coast of Madagascar. And folks in the big...
And I'd like to thank all of you for being here with us. I am here to answer all of your questions, and I think we have much better weather than the folks in Times Square have as they're watching. They are working on bringing together landing parties all around the world as part of NASA Social. So here are photos of a California Science Center NASA Social event.
Visiting later today. Things are getting more active for the team now. Let's check back in with Julie Wirtz-Chen in the control room. What's going on, Julie?
Yeah, so we've heard from MRO a couple of times. That's Mars Reconnaissance Orbiter. They are doing their slew. They're ready to support us. They're doing great. And we heard from both Marcos, Marco A and B, that they're out there. We've got telemetry lock with them from the ground stations here, so they're doing great. And everybody's ready to go. So we're pretty excited.
Fantastic. We will check back in with Julie in a moment. Meantime, this is a good time to tell you a little bit more about that technology experiment we've been talking about, Marco. As we mentioned earlier, InSight does not have an orbiter in position to send EDL data back live. So the CubeSats hope to fill that gap. Here's how they'll work.
Communicating between Mars and Earth requires a complicated choreography, with everything in the right place at the right time. Sometimes hours can pass before information is relayed from one planet to the other. That's why when NASA's Mars Insight lander launches this year, the rocket will carry 2 tiny satellites on a technology test of their own. Meet Mars Cube 1. Marco, NASA's first CubeSat mission to deep space. These briefcase-sized satellites will travel separately from the InSight lander while they test out new miniaturized technologies. And if they make it to Mars, they could relay information back to Earth about InSight's descent and touchdown, and do it in mere minutes. Although this fast communication isn't crucial to the success of the InSight lander, this CubeSat test could change the way future spacecraft phone home.
All right, let's check back with Julie to see if the Marcos are indeed ready to support and listen for InSight. Julie, what do you know?
So they are ready to go. I haven't heard about their slew coming up yet, but they are ready to go. We've heard from them. They're both healthy and they're both doing great, which is just wonderful news. So I think they should be doing a slew in just a minute. Actually, yeah, I think they should be doing a slew in just a minute.
We'll stand by and listen then.
So while we're waiting for that, to answer a couple of your questions, the CubeSats, if these work, will be used in future missions, not Europa Clipper, but probably missions after that as relay satellites that allow us to land things and, well, have to get less mass to the world we're getting to. So with the question, which is more difficult to land, a planet with an atmosphere or an asteroid without an atmosphere? It comes down to just how tiny is that asteroid. One of the problems with asteroids is they're rotating and they have very, very little gravity. Landing is easier when you have gravity. If we're comparing something like Ceres with Mars, Ceres is going to be a whole lot easier. It's the having some atmosphere but not enough to fully use parachutes like we have with Mars that makes things really challenging. If you have a World Lake series, you just retro rocket your way all the way down. Now with some of the smaller asteroids, it gets really frustrating. And this is where instead of trying to land on them, we just kind of bounce things around them. You may have seen that with our recent coverage of Hayabusa 2, where it went with several hoppers that went about 15 meters between each hop. So we are currently waiting to hear if things go well with the Mars Co separation.
All stations and systems, we can confirm we are entry minus 20 minutes. EDL Nav 2 has been initiated. The Star Tracker has been powered off.
That the Nav2 software has been initiated. So when we're in cruise, we use a star tracker in a similar manner to how sailors navigated years ago. We look at the stars and get our relative position from them. And we use a star tracker for that. And now that we're close enough to Mars, we don't need that anymore. So we're going to transition to what's called Nav2 software. And that lets us basically just use velocity and acceleration from this point on. So we don't need the star tracker anymore.
Salute to EDL bent pipe mode. Marco, clarify. Slew to inertial or started bent pipe?
Slew to appropriate attitude for bent pipe. Bent pipe mode will be entered shortly.
Okay, thank you very much.
And that was obviously our confirmation of the slew for Marco, so that's great news.
Fantastic.
So I was saying before that the Nav2 software will propagate from here on out, and we'll use velocity and acceleration. So we have powered off our star tracker, and we're on our Nav2 software, and everything's looking great.
Okay. Thanks, Julie.
Thanks.
All right, the cruise stage separation is just about 4 minutes away, and Rob Manning joins us now. Rob is the chief engineer here at JPL and an absolute veteran of Mars landings. We're going to play a little video for you right now. You haven't seen it yet, but we'll roll it. Let's go ahead. This is
Lander is still alive. 14 reports carrier log.
That day, Rob. There you are. You were the phase lead. You were sitting up front.
Yeah. That's what I look like when it's successful.
Yes.
I hate to see what it would have been like if I wasn't successful.
But talk about that. What is EDL like? Why is it so hard?
Well, it's many years of work by many, many people who struggle to put all the pieces together, and particularly because we can't really test entry, descent, and landing on this planet. It's much more complicated. Mars has a lower atmosphere, thinner atmosphere, less gravity. You just can't put the pieces. So imagine you had a big Broadway production, but you couldn't really do the show until all the audience shows up. So that's what it feels like. So you never really know if you've really done it right.
Well, we've done it 7 times. Can we say that, hey, piece of cake, we know what we're doing?
No, I don't think so. I mean, we get better at it, and there's no doubt. We've learned for both the successes and our own failures, including failures of other missions outside of this country. So those pieces come together in our mind's eye. We try to put what we learn together and just do the best we can. And if we don't succeed, we will learn, because we are collecting data on the way down. If something bad happens today, we'll be able to take what we learned, even though we may fall on the ground after getting kicked off the horse. We'll get back up, brush ourselves off, figure out what we did wrong, and get back on the horse.
Well, there's a lot of uncertainty. Just very quickly, give us some possible scenarios of what could happen during EDL today, especially during communications.
Well, the great news about having communications, there's almost anything that can go wrong. There's a very good chance we'll figure it out. But things like, the parachute has to go right. We know you don't open parachutes on Earth going Mach 1.5. 1.5 times the speed of sound. You just don't do that. You don't need to on this planet, but we have to, because if we waited any longer, we'd be on the ground. A very complicated radar system has to work from outer space all the way to the ground and look for the ground. What if it locked up on the heat shield? Well, we've tried to avoid that problem. We've fixed that problem, we think, to prevent that from happening. But what if we got it wrong? Things like that could happen, and our vehicle could have things bad happen. But we've worked hard to prevent them.
So
at this time, we expect
getting
that
close.
the
We're going to go to the
recording has
control room
started.
for cruise stage separation, Rob.
Okay.
Thank you, MRO.
I need to take off comment.
Someone's mic was still on. So now everyone is waiting. This is where your nerves start to get really tense. And it doesn't help that they all know that they're on NASA TV. I would definitely not want to be in one of those chairs.
Insight Systems, EDL
Go ahead.
on Insight Court. At this time, MRO will have loaded their electro sequences. Marco is expecting carrier lock at any time. Marco B is reported there in bent pipe. Still waiting on A.
Copy that. Thank you.
So they have carrier lock on one of the two CubeSats.
For you,
but not
science
both.
report, UHF carrier detected.
EDLCom, Marco Alpha is in bent pipe mode. Marco Bravo has locked on the carrier.
So now they have both.
Marco Alpha has also locked on carrier.
So we now have two suitcases.
As expected, the DSN has LOS for Insight Expand.
Copy that. Thank you.
So DSN is the Deep Space Network. It consists of radio dishes located in Canberra, Madrid, and Goldstone. Sue, that's awesome. If any of you are interested in doing interviews for CosmoQuest, we're currently interviewing people to find out
All
how
station Insight Systems on Insight Court. DSN has lost the X-band signal from Insight, indicated expected cruise stage separation. Standing by for UHF signal acquisition via Marco or radio science.
We are about 5 minutes from entry and have confirmation we've lost the X-band signal from Insight. This was expected because we have transitioned from the antenna on the cruise stage to the UHF antenna on board the spacecraft. Ground stations have detected the UHF signal and Marco has locked on the signal. This confirms that Insight is transmitting UHF signals as expected. Insight telemetry through the Marco relay is not expected until about 2 minutes before entry.
So, Rob, that was exactly what we were hoping to hear, that the
Yes.
Marcos are
The vehicle
working.
has also performed the turn to entry maneuver. The vehicle is turning away from a sun-pointing attitude and oriented itself to enter the Martian atmosphere.
This is a big first step. Getting the cruise stage separated. It's now, after the vehicle turns itself to the right orientation, the cruise stage is now going to be get further and further away until it's about 3 or 4 football fields away, and will burn up in parallel as the vehicle enters Mars.
And Christine mentioned turn to entry. What does that mean?
Well, it's because the cruise stage has to be pushed off to one side, like this. The rest of the vehicle has to turn to face the atmosphere and to be dead nuts on as it hits the top of the atmosphere.
So this is taking all the heat coming into the atmosphere.
Exactly. It'll be both provide a source of drag, but also thermal protection because it gets over 1,500 degrees Celsius on the top of on this heat shield. Very, very hot. But on the inside of the heat shield, it may be only a fraction of a few degrees above room temperature. So it's a wonderful protective device to keep our lander safe.
So another way to think of it is, if your spacecraft goes in like this, it has the greatest amount of surface area that will be dealing with the friction and working to brake. If it goes in like this instead, it has much less surface area, it slows down less, and crashes. So it's very important to get the orientation exactly right, which is why they rotate it.
Exciting.
And now we are standing by, waiting for that next thing to take place. They are in the process of getting ready to do that rotation to be at the correct inclination, that dolphin. I think actually with the delay, they've already done it and they're waiting for confirmation from the spacecraft. We're dealing with about an 8-minute light travel time delay from Mars now, which means that something happens at Mars and then the information moves through space. So, put a different way, Mars is currently the same distance from Earth as the Sun, more or less. And so we have to wait. Yes, Ambius, it's just like jumping in head on or belly on. You slow down more with the belly, and that is part of what causes the pain, but they use a heat shield.
Entry is scheduled for 11:47. The cruise stage SEP and the entry times are locked in, correct?
They are. They're locked in when we selected the target and aimed the vehicle very precisely. That allows us to know exactly when we hit the entry point, which is 55 kilometers from the center of Mars.
So we know those times are locked in, but what about all the other events that take place in EDL?
Reggie Science reports dropping carrier power as expected.
Marco A and Marco B have telemetry.
Just heard, both Marcos have telemetry.
They are doing their job. These small CubeSats are relaying ones and zeros with a few seconds lag from the vehicle up to these two vehicles, and they forward them back to Earth to the Deep Space Network using X-band antennas.
And keep in mind, this was all an experiment. We weren't sure that this was going to work, but we had this need that we didn't have live communication in this particular mission.
Well, we don't really need communications. We don't need their information, except if something went wrong. We would very much like to get the data right now. We have other spacecraft.
We are now receiving InSight telemetry via the Marco relay.
It's flowing into this station. This is fabulous. That means the team now can watch the data flowing onto their screens as if they're communicating directly.
This data will provide detailed information about the state of the spacecraft throughout EDL.
We were on pins and needles waiting for that because we weren't really sure.
This is wonderful news. This will allow us to give some, if this continues working all the way to the ground and beyond, we might even see a first picture from the surface of Mars.
Wouldn't that be great?
Very soon.
Atmospheric entry on my mark. 3, 2, 1, mark.
And now we wait. And we know nothing.
In a few seconds, the vehicle will start
but we know the
sensing
CubeSats are listening.
I said 22 kilometers from the center of Mars. And it's going to start to slow down very, very slowly at first, but then faster and faster and faster till it reaches about 7 Gs. I made that mistake on the video. It's actually 7 Gs, not 12. And so but we'll still very, very quickly slow down. And from 15...
In approximately 1 minute, InSight is expected to reach its maximum heating rate.
Oh, yes.
Plasma blackout is possible during peak heating and could cause a temporary dropout of telemetry. This could last for as long as 2 minutes.
Yeah, the gas that comes off the heat shield as it's slowing down, it looks like a meteor if you're on Mars watching the streak go by. That brightness of gas does interfere with the radio reception. And so it's possible that Marco will lose that signal while it's going through this very hot entry.
But not to be alarmed.
Not to be alarmed. It's part of the design. We completely expect it.
Radio Science reports plasma blackout as expected.
Okay. Oh, wow.
Ground stations have reported plasma blackout. still receiving InSight telemetry via Marco.
Marco Alpha has carrier interruption.
InSight should now be experiencing the peak heating rate. Portions of the heat shield may reach nearly 3,000 degrees Fahrenheit as it protects the lander from the heating environment.
That's hot.
Marco Bravo shows carrier interruption, but still in lock.
InSight has passed through peak deceleration. Telemetry shows the spacecraft saw about 8 Gs.
Marco Alpha and Marco Bravo maintain lock.
Radio science reports carrier detected.
So, several different communications coming in.
InSight is now traveling at a velocity of 2,000 meters per second.
Seems to have passed this very critical point of peak heating and peak deceleration. The next big step is parachute inflation.
And you can see that on our timeline on the bottom of the screen. The next event is parachute deploy.
InSight is now traveling at 1,000 meters per second.
Very close.
Once InSight slows to about 400 meters per second, it will deploy its 12-meter diameter supersonic parachute. The parachute will deploy nominally at about Mach 1.7. Standing by for parachute deploy.
Radio science reports sudden change in Doppler.
Ground stations are observing signals consistent with parachute deploy.
Doppler
Marco Alpha,
is
Marco Bravo maintain lock status.
change in velocity that is measured through change in
Telemetry
wavelength.
shows parachute deployment. Radar powered on. Heat shield separation commanded.
So what I was saying is G refers to Earth's gravity of 9.81 kilometers per second squared for acceleration.
This
it's
is
just
really
a
good
standard
news so
we
far.
It's fantastic.
I'm on pins and needles.
We have radar activation where the radar is beginning to search for the ground. Once the radar locks on the ground and InSight is about 1 kilometer
The
above
fact
the
that they
surface,
could lose the ground.
the lander will separate from the backshell and begin terminal descent using its 12 descent engines.
There aren't redundancies for the engines now.
Altitude convergence, the radar has locked on the ground.
Okay, they found the ground.
Standing by for lander separation.
Carrier interruption on Marco Alpha and Marco Bravo.
They have the 12 different ones so that they can better control things. It's
Lander
more stable.
separation commanded. Altitude 600 meters. Gravity turn, altitude 400 meters.
We're getting there.
300 meters. 200 meters. 80 meters. 60 meters. 50 meters, constant velocity. 37 meters. 30 meters. 20 meters.
It's going fast.
17 meters, standing by for touchdown.
Okay, now we wait.
Touchdown confirmed. Insight is on the surface of Mars.
It looks like they're lighting the room on fire. All those flashes were a bit terrifying.
Wow.
That's fantastic.
Okay.
This never gets old.
No.
Now we need to wait. Find out, do the solar panels deploy?
Just erupted.
Fabulous,
Shaking
fabulous.
hands with the Marco team there.
Christine, you did great. Tim Preiser, one of the key designers at Lockheed. Sandy Krasner, what a great team. What a great.
Okay, so now we made it. We are going to find out later tonight.
This is really fabulous.
When we get the information back from Mars Odyssey, whether or not everything is healthy. We are waiting to get the images back from Mars Reconnaissance Orbiter to just see what it looked like.
Lots of fist bumping going on in there.
Yeah, those descent numbers got me too, Torlap.
We've cut over to the camera over in Times Square. Boy, people are weathering the rain to see this.
That is true. No breakfast for Mars today. Let's starve that planet and simply crawl all over it. Or in this case, drill a hole.
They can't help.
Okay. So if you have any more questions, I'm going to lower the volume on the NASA feed because it's mostly clapping and happiness, which is as it should be. We now get to wait for data to come back. We get to wait to find out, did the solar panels deploy? It's going to take it time to get the seismometer deployed. It's going to take it time to hammer its thermal sensor into the ground. But we got it there. This is the most dangerous part. And now they're going to talk about why this is so important.
Understand that this vehicle is very complicated. It uses 12 engines. Each of those engines are pulsed 10 times a second, producing these little tiny impulses, almost like little bullets that keep the vehicle going at a constant velocity as it approaches the ground, and still going over 5 miles an hour. So those legs feel a fair amount of crush. We still don't know the state of the vehicle right now. We need to look to make sure there are no rocks nearby. The solar panels will be in just a few, in about 5 to 10 minutes, will begin to open up. They're waiting for the dust to settle because the dust there's certainly a lot of dust being lifted in the air around the vehicle right now, which is now just settling.
So we're standing by after touchdown. It waits a couple of minutes to give us an X-band beep. And so we are standing by for that. It's a communication that comes directly to Earth from InSight.
Yes. And it goes to the Deep Space Network. There's also something that might be happening now, if we're very lucky. InSight might be able to relay an image or a partial image taken just a couple minutes after landing. So I'm standing by hoping to see that. But if that doesn't happen, we'll certainly get more images later in our Odyssey pass in about 5 hours.
We see Bruce Banner waiting for it.
They're
I don't know if they see it yet.
They're waiting. That's Justin Mackey and Bruce Banner looking carefully at the cameras to see what they might see. They're waiting for the image to come back.
So this is the first image from InSight itself. InSight is taking a picture with one of its 2 cameras.
Yes.
It's probably a view of what's directly in front of the spacecraft, right in front of the lander. This is a camera that it would be using to figure out, is this a good space?
Exactly.
Is it a good place to put down our instruments? So it is going to take an image and send that image to the Marcos. The Marcos, in turn, will relay it back down to Earth.
That's correct. They got it. Oh, now let's just wait. Let's see what they saw. There it is. Whoa, right.
That is the worst cheered for image. We've clearly got dirt on that thing. Hello, Mars dirt.
That's not far from where we'll be able to deploy the instruments. So it's great. I don't see a lot of.
Let's explain that image. Now, this image has a dust cover on top of it.
EDL.com, we have lost a signal for Marco.
You can see potentially a lot of
radio science reports
debris that might be on the camera.
LOS for UHF.
So we don't know what I'm looking at.
Thank you, everybody on EDL.com.
All right.
Yeah. Yay, Marco. Congratulations.
Meantime,
oh, there it is. You can see a better view. You can see that really is debris. And there's the horizon back there, the bluish sky. That's part of the lander deck on the front left.
The dust cover
I can't make out, but it looks like there's not a lot of rocks in the field of view. But those dots you see there are very likely to be dust particles on the lens, the dust cover, which will be removed.
And we'll get another shot later on.
Yes. And a better, clearer view after the dust cover is removed. So Insight's, CubeSat's relay communications job is done. They're now flying on. They're now taking pictures back toward Mars. Hopefully, MRO, which flew overhead, might have been lucky enough to capture the descent of this InSight lander under its parachute. While this was going on, MRO was flying overhead, recording the data, also monitoring the transactions and recording every bit of signal it could. But it also had the ability to take a picture, and maybe like we did with both Phoenix and later for Curiosity rover, we might be able to see the parachute inflated as well.
That would be fantastic. We are standing by now for that X-band beep.
Yes.
InSight phoning home saying, I'm here and I'm okay.
So MRO is a sister spacecraft to the Lunar Reconnaissance Orbiter. They're actually pretty much the same hardware. They're extraordinarily high-resolution imagers. It's MRO that is the spacecraft that carries HiRISE with it. This is a spacecraft that gives us basically meter-resolution images of Mars. Thank you, Canada Kim, for the subscription. As always, this show is made possible thanks to your bits, your subscriptions, your donations. Everything is appreciated.
System based on InSight Cord, the DSN and X-band.
Radio science reports X-band carrier detected.
Okay.
The DSN and X-band radio science have acquired the X-band touchdown signal for InSight. X-band will continue for 4.5 minutes with InSight in nominal mode.
Copy that. Thank you.
Flawless.
Perfect.
Flawless.
We've got the beep. This was perfect case scenario.
This
is
what we really hoped and imagined in our mind's eye. Though we spend most of our visualizing all these bad things can happen. Sometimes things work out in your favor. And
okay, so we have a perfect landing. We have an image returned while the dust cover is still over the camera. Future images will not be taken through the dust cover, so we can expect clearer views of the Mars surface. Here is to hoping the solar panels deploy correctly. Here is to hoping the seismometer can be deployed correctly. And then comes the challenge of digging things down. Thank you, M. Coupon, for the 100 bits. Thank you so much. So this is one of those amazing opportunities for us to be able to understand the inside of the red planet. Thank you, Lancy. Thank you so much for the 1,000 bits. No, Ben Science and Games, I'm not that good a scientist. Oh, something's coming back.
So we're all nominal on the surface.
So the vehicle is completely nominal, reported nominal. It's happy. The lander is not complaining. We had a way to tell us if it was unhappy, and it wasn't. It's not unhappy. It's in a normal.
So the way they're doing this is currently, the lander is sending back a series of specific beeps. One kind of beep means I'm healthy, another kind means I'm in trouble. These can be detected from both Goldstone and from the folks at Max Planck in Germany. So they are now taking off. Thank you for the follow, Trillian. Thank you for the bits, Venti Latte. So I'm going to hang around a few more minutes. I'm going to answer your questions. Thank you, Wonky, for the follow. And we will be bringing you updates on the mission tomorrow from the Daily Space. The Daily Space will be airing tomorrow at 1 p.m. Eastern, 10 a.m. Pacific, 6 p.m. London time. Now, spacecraft like this are designed to only last a certain period of time. They are funded to only last a certain period of time. But that's never stopped an engineer from making things, well, a little more rugged than was necessary. So now comes the question of just how long will this spacecraft last? It could be the solar panels don't deploy and it's just about done in. It could be everything goes great and 5 years from now we're still talking about the results it's bringing in. With its particular seismometer, it's going to be able to detect new rocks hitting the surface of Mars. This is incoming meteorite impacts. Those impacts will shake the red planet just enough for us to see what's inside its core. Thank you, Canada Kim. Thank you so much. We will be here Monday through Friday, except on holidays, to bring you updates of this and all else that is coming to you from the worlds of astronomy and space science. This program is part of our live event series. We are working, myself, Annie Wilson, and Matt Richardson, to bring you, well, more than just the Daily Space. We have Astro 101 courses. We cover launches and landings live whenever we can. And we want to be here as your place to enjoy space together. Let's learn and do science. Together we can study our universe. Now, unfortunately, these explorations are only made possible with the help from people like you. Coming January 1, we no longer have one of our largest NASA grants. This means we're trying to make up a deficit of funding while we look for new funding. We were warned this might be coming. We were warned that James Webb Space Telescope cost overruns might be costing us our funding. And they did. So if you want to see us keep going beyond January 1, please consider making a tax-deductible donation where tax deductions are allowable by law to CosmoQuest. We are part of the Planetary Science Institute, working in collaboration with Youngstown State University. In order to help us raise money to, well, keep going, we are going to be holding a massive fundraising event on December 22nd and 23rd and into the first few hours of Christmas Eve. So stay tuned for more information on that, and scroll down here on twitch.tv/CosmoQuestX and find out all the different ways that you can help us keep our programs going. We just want to help you learn and do science. This has been a great day, and I am so amazingly grateful for all of you being here to, well, share this non-impactful experience, because everything went well and there was no crashing. I'm so grateful to have all of you here sharing this non-impactful event with us. And I just want to say we couldn't do this without you. And I want to thank you for all the things that happened. Oh, wow. The follows are coming fast and furious right now. So thank you, going back to the beginning of today. Thank you, Haven Rose, for the follow. Thank you, Saintapus, for the follow. Thank you, Sue Bachelor, for the sub 1, for the tier 1 sub. Thank you, Dat Dolphin, for the donation. Thank you, Blue Kobold, for the follow. Thank you, Rocket Sage, for hosting. Thank you, Bad Panda, for the sub. Thank you, Fenmill. Thank you, Michael. Thank you, Astro YYZ. Thank you, M Coupon, for the bits. Thank you, Lancey, for the bits. Thank you, Trekker Kev, for the bits. Thank you, Ventilante, for the bits. Thank you, Canada Kim, for the bits. And there's so many follows that I'm just going to let it scroll on by. Thank you, everyone who was here. You really make this possible. We wouldn't be here without you. And thank you. And wherever you are in the world, remember, you can go outside, you can look up, and the red planet is in your sky tonight. So please go out and explore. And once again, thank you all for everything you do that makes this show possible. And wherever you are in the world, have a wonderful morning, evening, or afternoon.